Welcome to Larry's classroom. Today we're going to begin our first lesson in mathematics for electricity and electronics. And of course we're going to start with some basic arithmetic review. We got the four operations that we typically use: addition, subtraction, multiplication, and division. Subtraction is basically the inverse of addition. It does addition. If we take an example of addition, 6 plus 4 is equal to 10. Well, the corollary to that is 10 minus 4 is equal to 6. So here we use addition, here we use the subtraction, and the subtraction undid the division. We got back to where we started. 6 plus 4, here's where we ended. We added 4, got 10. We took away 4, got back to 6. And multiplication works pretty similarly. Multiplication, division. Division undoes multiplication. We have this example: 3 times 8 is equal to 24. And by the same token, 24 divided by 8 equals 3. So we started with 3, and we ended up with 3. We took the 3 we started with, and we multiplied times 8. We ended up with 24. Here we divided the 24 by 8 and got back to 3. So we can see that addition, subtraction, and multiplication and division are inverse functions. They undo each other. Another important thing to think about: we have what are called the commutative laws. And basically, to commute means to go back and forth. So the commutative laws indicate that things go both ways. We say that if we think about addition, we say that x plus y is equal to y plus x. And for multiplication, we say that x times y is equal to y times x. What we're saying here, it doesn't matter what order we do the addition, it doesn't matter what order we do the multiplication, we'll get the same results. So we're going to think about a few simple examples. If we go 5 plus 3 equals 8, by the same token, 3 plus 5 equals 8. The order didn't make a difference. Sometimes I think it was just the order doesn't make a difference law, commutative law. 7 plus 3 equals 10. 3 plus 7 equals 10. Order don't matter with addition. And multiplication, 2 times 5. Sometimes we use a dot to indicate multiplication, but I'm going to stick with a little x for right now. 2 times 5 is equal to 10. Reverse order, 5 times 2 is also equal to 10. 3 times 4 is equal to 12. 4 times 3 is also equal to 12. So the commutative laws say that it doesn't matter which order you do your multiplication and division. They are interchangeable in order, You get the same result whether you do the addition or whether you multiply one against the other or vice versa. Subtraction and division, now they are not commutative. 10 plus 4, this is addition, equals 14. 4 plus 10 equals 14. So addition is commutative, but if we go, it's commutative. The commutative law applies to addition. But 10 minus 4 does not equal 4 minus 10. We could have wrote this up here as 10 plus 4 is equal to 4 plus 10. I chose to calculate the value and show you that we got the same value, but we could do this also. 10 minus 4 does not equal 4 minus 10. And this is a new symbol here for some of you. We have the equal sign. When we draw, if we draw a line through it, that means not equal. So I've used the not equal sign here to say 10 minus 4 does not equal 4 minus 10. And that, if it was commutative, it would, but it is not commutative. Subtraction is not commutative. So we cannot reverse the order of subtraction and expect the same results. And the same is true with let's start with multiplication again. Let's go 3 times 5. And let's just say that's equal to 5 times 3. Instead of doing it twice like we did before. We can see that'd be 15, that'd be 15. Multiplication is commutative. Division is not commutative. Is not commutative. I'll give you an example here. 20 divided by 4. That will equal, that's going to equal 5. But 4 divided by 20 will equal 1/5. Well, 5 does not equal 1/5, so division is not commutative. So we got to make sure we keep our order the same as intended for division if we want to get the right answer. And we'll do one more here. 50 divided by 10. That's going to equal 5. Oh, I don't like that example. Let's go 30 divided by 5. That will equal 6. 5 goes in 36 times. If we reverse the order, 5 divided by 30, that will equal 1/6. And again, 6 does not equal 1. 6 does not equal 1/6. So division is not commutative. Now let's summarize real quickly on commutative and not commutative. Commutative. Multiplication, and addition. Not commutative. Division and subtraction. So we've reviewed quickly the commutative law, and we know that we can Do multiplication and addition in any order, no problem with the result. But division and subtraction must be done in the intended order or will not get the correct answer. We're going to talk about what are called associative laws. A plus B plus C. These are variables. Letters are variables. They could represent any number you wanted to put into them. It could be 2, 4, and 7, 3, 9, and 6, whatever applied to your particular situation. Now the parentheses indicates to do that section first. Yeah. To do is in the parentheses before you do. So here you would add up the A plus B, then you'd add the C. Here you would add up the B plus C, then you'd add the A. So what we're saying here, we're associating in this case the B with the A. In this case we're associating the B with the C. And what we're saying here is that addition is associative. Is associative. Example, if I have 3 plus 7 plus 2, I add the part in parentheses first, I get 21 plus 2. Now we add the what's left. 21 plus 2 is 23. If I take the same problem and associate it differently, so now I'm going to add the part in parentheses, 7 plus 2. So I got 3 we ain't doing nothing with the first time. 3 plus 7 plus 2 is 11. No, it's 9. What am I doing wrong here? Oh, I see what I did wrong. This is 10. 10, 10, 10. Okay, 3 plus 7, part parentheses, that was 10. Plus 2, that was 12. Got to learn to add correctly. 3 plus 7 plus 2. 3 we don't change. 7 plus 2 becomes 9. But again, 3 plus 9 is 12. So the way we associated the 7 did not change the result. We'll do one more down here. I'll use a different color. 2 plus 9 plus 6. 2 plus 9 plus 6. We'll associate that one this way. So here we're going to associate the 9 with the 2 the first time. 2 plus 9, we do the part in parentheses before we do the other part, gives us 11 plus 6. Now we do the what's left. 11 plus 6 gives us 17. Now here, instead of associating the 9 with the 2, we associated the 9 with the 6 by putting the parentheses on there. And we do the part in parentheses ahead of the other. 2 plus, what's in parentheses? 9 plus 6, which is 15. And 2 plus 15 is also 17. So we can see that how we associated, not only does the order not matter for addition, how we associate them, a string of addition, when it's all addition, doesn't change the outcome. And multiplication is also associative. So we use basically the same variables, A, B, and C, just like we had originally. I'm going to say that A plus B, and remember, a variable is just a container for a number. Some number, when you do a problem, will be plugged in there to replace it, or we will find some way to find out what number belongs in there. A plus C equals A plus B plus C. Now we're going to associate this as A plus, well, this is times. We already did the plus example. We're going to do times, 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 times. So, what I'm saying here A plus B plus C, if I associate the B with the A, or if I associate the B with the C by using the parentheses, then I'm going to get a similar result. Well, let's do a couple examples. Let's do 2 times 3 times 4. And we'll do the same example, but we'll associate it differently. So here we have 2 times 3 times 4. Here we associated the 3 with the 2 using the parentheses. Here we associated the 3 with the 4 using parentheses. So we're going to do this part in parentheses first. 2 times 3 is 6. 6 times 4. The next step, do the 6 times 4. We get 24. Now here we've associated differently. We want to do the part in parentheses first, so we're just going to take the 2 times and do nothing with it on the first pass. 3 times 4 is 12, so we use the 12 there. Now the next pass, 2 times 12 becomes 24. So you can see how we associated the addition did not change, or the multiplication did not change the result. And we also, but subtraction and division are not associated. You cannot apply this associative property to division. So we're going to write associative. Multiplication and addition. Not associative. Division and subtraction. I suppose I should do an example. Let's try an example. Let's go 4 divided by 2. Got an example here, that's a good one. 4 divided by 2, and we divide by 2 again. Let's see what I get here. 4 divided by 2, I'll put the parentheses here. 4 divided by 2 is 2, and we're going to divide that by 2. So 2 divided by 2 is 1. Take the same thing, 4 divided by 2, associate it differently. Do the part in parentheses first. We won't do nothing with the 4. 4 divided by, now we do the part in parentheses, is 1. 4 divided by 1 is 4. So you see we got a different answer when we associate them differently with division. And let's do one with subtraction too. Let's go 10 minus 3 minus 7. Okay, yeah. 10 minus 3 minus 7, and let's go 10 minus 3 minus 7. Okay, those are 2 examples that we're going to do. 10 minus 3, in parentheses, becomes 7. Minus 7, you didn't do anything with that, equals 0. Now, 10 minus what's in the parentheses. 3 minus 7 is minus 4. We haven't worked with negative numbers yet in this course, but it's negative 4. And now when we go 10 minus minus 4, that's like going 10 plus 4. That equals 14. So you have to be careful on associating numbers. You don't want to extend the associative property to division or to subtraction, but it's good with multiplication and division. did the distributive law. We're going to talk about order of operations now. Order of operations, tricky thing that sometimes trips people up. Order of operations. Important to learn this and get it correct. First thing, which we demonstrated in our associative in our distributive properties a little bit ago, is that, well, in our distributive property, parentheses. Whatever comes in the parentheses, we want to do that before anything else. And then, after that, we do multiplication and division. And we do that in order from left to right. And then we do addition and subtraction from left to right. So, kind of our normal order to doing things is left to right, multiplication, division, then go through again left to right, addition, subtraction. But we use parentheses when we choose to override that type of a situation. We're going to do an example here. I'm going to erase this and I'm going to show you a little acronym that people like, a little memory aid. It goes like this. Please excuse my dear Aunt Sally. And you notice I've capitalized these first letters of each word. Please excuse my dear Aunt Sally, or some people say dear Aunt Sally. But that's to remember the P, E, M, D, A, and S. So P was like we just talked about, parentheses. The E, we haven't really talked about it yet, but that's exponents. M is multiplication. D is division. A, addition. And S is subtraction. I'm going to underline. You notice I've used all the underlined letters here. So this matches up the first letters of that memory aid word. And an important thing to remember, we work from left to right, but I'm going to circle a couple of these for a very good reason, I think. I'm going to circle multiplication, division, and I'm going to circle addition and subtraction. The reason that I've done that is even though multiplication comes ahead of division in the memory aid, and addition comes ahead of subtraction in the memory aid, they really have the same precedence. We do multiplication and division from left to right, picking off the multiplications and divisions as we come to them. When we get down to this step, we do additions and subtractions from left to right, picking them off as we get to them. So really, the first thing I had there, parentheses, division, Addition, subtraction, that was basically this, this, and this. The exponents go in here, but exponents are sort of multiplication anyway, but we'll worry about those when we get a little further down the road on this thing. But we'll do a couple examples here. I'm going to put a little calculation. 3 times 15 minus 20 plus 8 divided by 2. What does that equal? Well, we want to do anything in parentheses first. Do we have anything in parentheses here? No. There's nothing in parentheses. We don't need to worry about that. Next thing we want to do is the multiplication division, starting from the left, going to the right. So 3 times 15, 45. We ain't going to do no subtraction yet, so we'll just leave that alone. We ain't going to do no addition yet, leave that alone. But 8 divided by 2, we're going to do that. That's 4. So we've done the multiplication and the division for this step of the order of operations as we approach them from left to the right. So now we're done with the multiplication division. We got no more multiplication division? No. So now we're going to do addition and subtraction from left to right. So we're going to do the 45 minus 20. That becomes 25 plus 4. And 25 plus 4 is equal to 29. So you can see we went through, in one pass we did the multiplications and the division. The next pass we did the additions and subtractions as we came to them. We came to a subtraction first, didn't we? We got 25, and then we added the 4, we got 29. It's important to get these orders of operations down to where you understand them well. We're going to do another example here. Five times 13 minus 12 plus 8 divided by 4 times 3 equals. What does that equal? Well, P, please, parentheses. Do we have any parentheses? Yes. So let's go through and do the parentheses first. So we're not going to do anything with this yet. 5 times 13 minus, what's in the parentheses? 12 plus 8, that's 20. So we've done that parentheses part on the first pass. The only thing we did on that first pass was the parentheses. If there had been another parentheses over there, we would have done that. But we took care of all the parentheses. Now what do we have left? We have a multiplication, we have subtraction, we got a division, another multiplication. Now we're on the multiply-divide precedence level of the order of operations. So we're going to start at the left, we're going to do the multiplies and the divides as we come to them. 5 times 13, well that is 65. We don't want to do subtraction because we got division over here to do. Right, but 20, okay, that's, yeah, 20 divided by, so we're going to do the division next. We leave the subtraction alone, we have a 20 divided by 4, so that becomes 5. I think I want to do these just one step at a time. Minus 20 divided by 4 times 3. First pass, we did. Yeah, I guess I'm going to do them left. 5 times 13. Bang, we're going to do that on the first pass, which gives us, and this on the first pass, which gives us 65 minus 20 divided by 4 minus 5. We still have the times 3. So we did this first multiplication. We did this division. This division here. We haven't done this multiplication yet because we wanted to have this here to work with. So we still have a multiplication, so we don't want to do subtraction. 65 minus, now we want to do this multiplication. 5 times 3, 15. 65 minus 15 equals 50. So we started with this complicated string of numbers. We had a parentheses, so we did that first. made the 12 plus 8 into 20. Then we went through and did this multiplication, made that 65. Then we did this division and made that 5. And we brought this one just directly down. We could have just multiplied 5 times 3 and made the 15. It would have been, but it's a little simpler, I think, if you calculate this, rewrite it, then do that. See, now we have only one multiplication left. Right there, we did that multiplication. Now we have just subtraction. We're able to complete our problem. I'm going to leave this order of operations stuff up here right now. We think of a fraction line as pretty much a division. In other words, if I say 34 plus 11 over 5 minus 2, that's the same as, this fraction line also not only acts as division, it acts as a parenthesis. So we could take and put a parenthesis around everything above the fraction line and on everything below the fraction line. It doesn't change anything. That fraction line has an implied parenthesis in it. So this is the same as 34 plus 11 divided by 5 minus 2. So let's go ahead and work that out. 34 plus 11, we do the part in parentheses, that is 45. Divided by, do this part in parentheses, 5 minus 2 is 3. Well, 45 divided by 3 is 15. So this fraction is the same as 15. We did that by doing the part above the fraction line, using the implied parentheses to get the 45, doing the part below the fraction line, using the implied parentheses to get the 3, and then we recognize that the fraction line and the division symbol have the same meaning, so we wrote it that way, just used the divide, and said 45 divided. We could have said, we could have done it this way. 4 plus 11 over 5 minus 2. Recognizing the implied parentheses, we could have said 34 plus 11 is 45 over 5 minus 2, which is 3. But when you did the division, you would see that it was 15. So basically, two things we wanted to point out here. That the fraction line acts like a parentheses, and that the fraction line and the division is the same operation. We're going to do a little more involved example here. $60 divided by 8 minus 2 plus 4 times 15 minus 10. And what does that equal? We want to work that guy out. Well, remember, this is like a parentheses. We have a parentheses here. This is like a parentheses because we have the fraction bar. So we're going to do the parentheses from left to right. So we're going to say 60 over, what's this thing? 8 minus 2, that's 6, right? We've done this piece under the fraction bar using the implied parentheses of the fraction bar. Plus 4, don't change anything with that yet. Multiply, we don't want to change anything with that yet either because we want to do the part in the parentheses. 15 minus 10 is 5. Now, we've reduced our problem a little simpler than we started with. We have here a division, because remember we said a fraction bar is a division. And here we have a multiplication. We've got rid of the parentheses. We did that first step. Now we're on the multiplication and division part. We do that from left to right. So let's do it from left to right. Let's do the first division. 60 divided by 6. That is 10, right? 6 goes into 60 10 times. Plus, we still have a multiplication. 4 times 5, that's 20. So we did the multiplication division in the order we came to them, going from left to right. We have no more multiplication and division, so we are done with this piece. What's left? The subtraction. Addition. We don't have 10 plus 20, that's 30. So this kind of complicated expression that we started with, 60 over 8 minus 2 plus 4 times, in parentheses, 15 minus 10 is actually equal to 30. And just for a reminder, I'm going to put in blue here the implied parentheses that are done by the fraction bar. So I think that's enough for our start of mathematics for electricity and electronics. We've done a little bit of quick review of commutative laws, of associative laws, of distributive laws. We've seen that commutative laws apply to multiplication and division, but they do not apply to division and subtraction. We've seen that the distributive law applied to multiplication. Did we do this? I don't think we did the distributive law. We better do the distributive law. I don't think I did that one. Yeah, we better talk about the distributive law before we quit. Now, that's the one I missed. Okay, I'm going to erase all this stuff. We did order of operations. We don't want to forget about distributing. A times B times C equals. And A, so this is a B plus C, excuse me, B plus C. So what we have here is we have a multiply and we have a plus. If we had all the numbers, we could do the part in parentheses first and solve for the thing. But we can, what they call, distribute the A over the B and the C. And I'm going to draw arrows in 2 different colors to represent distributing the A. We distribute the A to the B, and we also distribute the A to the C. And what does that mean? When we distribute the A to the B, we have A times B. We still have the multiplication plus A times C. So we distribute the A to the B, we distribute the A to the C for the multiplication part, we still have the plus right here. So let's do an example, see how that comes out. 3 times 2 plus 4. First, let's do that the way using the order of operations. We would do the 2 plus 4. 2 plus 4, we would say that's 8. Then when we do the multiplication, we get 24. So let's do the same problem using the distributive property. So we're going to distribute 3 to the 2. 3 times 2, just like we distributed the A to the B. We're not going to do anything with the plus just yet. We're going to distribute 3 to the 4, just like we distributed the A to the C. 3 times 4. Now we're going to do the parts in the parentheses. 3 times 2, that's 6. Order of operations, multiplication ahead of addition, parentheses ahead of everything. So we're doing the parentheses. We're not going to do anything with addition yet because it's lower precedence. 3 times 4 times 2 is 6. 3 times 4. Okay, what am I doing wrong here? 6. Oh, okay, I see what it is. Ah, there we go, there we go. 2 plus 4 is not 8. 2 plus 4 is 6. 3 times 6 is 18. Okay, so we distributed, we did the parentheses, we got a 6. 3 times 6, we got an 18. Now we did the distribution. 3 times 2 plus 3 times 4. 3 times 2 was 6. The 3 times 4 is 12. 12 plus 6 gives us 18. So we got the same answer using the distributive property or using the order of operations. Now sometimes this was a simple example. It didn't really matter. It was pretty easy to do it this way. But sometimes we have complicated expressions. Using the distributive property can make your life simpler to do this stuff. So yeah, let's do one more little example of 18 plus 36 over 4 minus 1 minus 5 times 2. Okay. This fraction bar is like parentheses, so we can throw some parentheses in there just so we don't forget. What does this equal? Make that simple. So let's do our part in parentheses first. 18 plus 36, that comes to 54, right? Then do the 4 minus 1. That comes to 3. Now to do the subtraction, we're going to do the 5 times 2. That's 10. $54 divided by 3. What's 54 divided by 3? I'm going to do that in a calculator, make sure I don't mess it up. Okay, that's 18. So this is a multiplication, this is a division, this is a subtraction, so we still have multiplication division has higher precedence. We did parentheses, and we did the multiplication after we did those parentheses. Maybe I think I'm gonna do that in one more step. Okay. So we just did the parentheses here, right? Now we're going to do our multiplication, division left to right. Here's a division. There's 18. Nothing is subtraction. We're going to do the multiplication. That's 10. 18 minus 10 gives us 8. So we took that thing, we used the fraction bar with implied parentheses, we drew them on there. They weren't there provided originally. We drew them in as a reminder. We did what was in the parentheses. Brought the problem back down. Now we did the division. I'm going to make a note here that says division so you can kind of remember that's division. That fraction bar is division always. So we did the 54 divided by 3. That's 18. And we also did the multiplication in the order we came to it. That was 10. I'm going to draw some arrows too. That was 54 divided by 3. This was 5 times 2. Now we only had subtraction left. If there had been an addition, we'd done them left to right, but we only had subtraction. We ended up with 8. So that's probably enough for today. I always recommend that, this course is a course in mathematics for electricity and electronics. I would recommend you get yourself a book on that subject.
do practice problems. Mathematics always requires practice problems. It's, if you want to stay on top of things, you need to practice to get good at what you're doing. Without practice, it just takes practice to do math. Don't forget that. Anyway, thanks for coming back. Remember to like and subscribe. And until the next time, keep on learning.